composition of function or composition of functions is the entire activity of a function operating on another function. What we are most often accustomed to is having a function like f of x is equal to 2x minus 3 operating on a number like 5. So we have f of 5, and all that it is required of us is to replace the x with 5. And our work is done. So that will be 10 minus 3, which is equal to 7. So that's your function operating on a regular number. And as you can see, the function operating on a number like 5, the result is a number. However, when a function operates on another function, the result is also a function. And that function is called a composite function because it is a composition of 2 or more functions. Now, for the composition of functions, we have that expressed like this: f of g, f operating on g. Maybe this is a smaller like that, f operating on g. So that is saying f of g, or f is operating on g. Also, we have f operating on g may be written like this: f of g. Sometimes the x is given, so we have f. So f is operating on g of x. So we have f of g of x. All of these mean the same thing. F is operating on g, f is operating on g, f is operating on g. And the simplest form that we have is just f of g. Some students say fg. It's not fg, it is f of g. F operating on g, like f of x, f operating on x, generally. Or we have f of 5, f operating on 5. And as we said, function operating on just another number, an ordinary number, the result is a number. But when the function operates on another function, the result is generally another function, which is called a composite function. Now, we have to begin by taking what we call an error correcting step. And why do we need an error correcting step? We need an error correcting step because when composing functions, there's a common mistake that students make. And the most common mistake that a student makes is substituting the wrong function into the other. So, for example, we are required to find f of g. We are required to find f of g. When we are through, the result that we find is actually g of f. And if you understand the composition of function, by the time we are through today, you will realize why it is not a good thing or not a good idea to express f of g whose result will turn out to be g of f instead. It is not like your regular mathematics where you are asked to multiply 5 by 7 and you ended up multiplying 7 by 5, which will give you the same result. For a function, it is not the same thing. So we have to make sure that we make an error correcting step. Now, that error correcting step will be that we do not substitute from the very beginning. We don't substitute from the get-go. We write an expression that will f of g, which is actually f of g of x, what do we do? In the same manner that we say f of x is 2x minus 3, f of 5 is 2 5s minus 3, we may even say f of triangle will be 2 triangle minus 3. If we're going to say f of g, it is still going to be simply 2g minus 3, which you imagine is a no-brainer. You think that you could just, anybody should know that. Then, if everyone should know that, it would be good if we start off by making this simple step. After making this step, it is highly unlikely that the student will go on to make the typical mistake that students make. So, we start by saying f of g is equal to, let us take a look at f. F of x is 2x minus 3, so f of g must be 2g minus 3. 2g minus 3. Nice. What do we do then? Next, we substitute the algebraic expression of g. So we do the substitution next. So after we have this step, which is correct, it is highly unlikely that we will make a mistake in the next one. So 2g, what is g? This. X plus 1 over 3 minus 3. So that is 2g minus 3, then we substitute the algebraic expression of g inside here. That's nice. That's all there is to it. Now, when you're doing an examination, it is good if every step of the way you are accumulating steps. You're surely going to get that step for doing this because you are stating categorically, explicitly, beyond the shadow of a reasonable doubt, that you understand what f of g means. And then you continue. And for every step that is legitimate, you will accumulate marks. What do we do next? Who can see this? 2x plus 2 over 3 minus 9 over 3. Who is able to see that? Well, I know what you have there. Where did the 9 over 3 come from all of a sudden? Well, if we divide 9 by 3, we will get 3. So, what we have here as 9 over 3 is still this. Therefore, we are pretty much running on the same spot. Also, if we are going to multiply 2 by this fraction, some students will say 2 times x is 2x, 2 times 1 is 2, 2, 3, 6. And you know that multiplying the denominator by 2 is incorrect, but that's a typical mistake that students make. Well, I'm getting an error message on the screen, and for those students who are watching, if there is any difficulty that you have, could you just please send me a message, whether it's in the class group or it would be better if you make that, if you send that message inside of the chat. So if you make this message in the chat, then that will be better for me because I have seen it immediately. But you can also make it in the group. So, there is no doubt that if you are going to multiply this by a fraction, well, in normal mathematics we say that this is called a rational number, meaning that it can be expressed as a fraction. And you know already from primary school that 2 is actually 2 over 1. And when you are multiplying fractions, the numerator will multiply the numerator and the denominator will multiply the denominator. So that's correct. And of course, because we have a denominator of 3 here, what we do is number with a denominator of 3 also. So the combination here, the addition, or in this particular case, the subtraction is quite smooth. No problem. Subtraction is quite smooth. So all that we have is f of g is equal to 2x, and then what do we have? 2 minus 9, that will give us negative 7 all over 3. And that is your f of g. For number 2, we are going to have f of h. What is f of h equal to? F of x is 2x minus 3. So f of h must be 2h minus 3. 2h minus 3. Then what do? We substitute the algebraic expression for h inside there. So we have what? 2, what is h? X squared plus 4x plus 4. Right there. Right. So we have the boogeyman, Mr. Bugatti from Canada, tuning in from work. And I'm asking if it's coming through quite clearly, and I need a response if it's coming through quite clearly, because we have an error message on the screen at the moment. Okay, so 2 times h minus 3. So what do we have? That will be equal to 2 times x raised, so 2x squared plus 8x plus 8 minus 3. And finally, f of h is equal to 2x squared plus 8x, and 8 minus 3 is 5, and we are done. So that's your f of h. Number 3. G of h. G of h is equal to, now we're going to look at g of x. G of x is equal to x plus 1 over 3. So g of h must be h plus 1 over 3. So we have h plus 1 over 3. And of course, this first step is your error correcting step. That's your error correcting step. Why do we need an error correcting step? Well, sometimes we don't need it, but in a like that, it's a common student. That's where the students generally make the common mistake. So we are making an effort to ensure that we do not make that mistake. And what do we do next? We substitute, because this is number 3. We substitute the algebraic expression of h right there. X squared plus 4x plus 4 plus 1 all over 3. So g of h is equal to x squared plus 4x plus 4, well, we're not going to be plus 4. 4 plus 1 is equal to 5. 5 over 3. And that's all there is to it. Number 4, what do we have there for number 4? G of f. G of f, what is that equal to? G of x is x plus 1 over 3. So g of f must be f plus 1 over 3. F plus 1 over 3. And next, we substitute the algebraic expression for f right there. So what do we have? F is 2x, see? F of x is 2x minus 3. So it's going to be 2x minus 3 plus 1 all over 3. And g of f is equal to h of x is x squared plus 4x plus 4. So h of f must be f squared plus 4f plus 4. F squared plus 4f plus 4. And I told you so. What did I tell you? I told you that most of the students will forget what to do with this f squared when we are required to do what's necessary. So we will go straight ahead. We'll go straight ahead and make the substitution. Of course, f is 2x minus 3. So we're going to have what? 2x minus 3 all squared plus 4 times 2x minus 3 plus 4. All of this may go. And that is your composition. Well, the composition of your function. For sure. Now, as I said before, that is where students generally forget. And I'm saying that students generally forget right here. What do students generally forget? They generally forget what to do with the perfect square. Yes, they generally forget what to do with the perfect square. When they get the perfect square, they'll make a meal of it. But I'm here to remind you that for the perfect square, we should have this 4x squared minus 12x plus 9. That is what is going to come from inside of this bracket. And then what we will have next is 4 times 2x is 8x minus 12 plus 4. So we have 4 2's 8, so that's 8x, 4 times negative 3, negative 12, and there we go with that 4. The perfect square will be, the first one squared will go there. 2 times the first times the second will go here, and square the second, it will go there. So at each end, we will have the square of this one, the square of the other, and in the middle we have 2 times this times this. Now we have an entire audiovisual on the perfect square. Therefore, we need not, right? Therefore, we need not teach the perfect square right here, which will take the entire time. So you can go to that audiovisual in my YouTube channel, the same channel that you're in at the moment, and you will see an entire audiovisual on completing, not completing, but the perfect square, and also the difference of two squares. Now we'll put this together. H of f is equal to, the square term will go, then what will happen? Negative 12x plus 8x, negative 4x. And then what else? 9 plus 4, that's 13, minus 12, that gives you a positive 1. So that is what h of f is equal to. Now, if we take note of f of g, which we have right here, and g of f, I'm going to try to find that g of f on the board. G of f is right here. Also, we have another pair, f of h and h of f. We have another pair, f of h right there, and h of f right here. What do we notice? We notice that f of g is not equal to g of f in this particular case. Also, f of h is not equal equal to h of f. Right. And some of us would expect that f of g would be equal to g of f. We see that happening in our regular addition where 5 plus 4 is equal to 9 and 4 plus 5 is equal to 9. We see that. And because the order in which we add the numbers does not matter, we say that addition is commutative. Well, because the order in which we compose function does matter, because if the order changes, the answer changes, then we say that the composition of functions is not commutative. And that's a very important thing to take note of when we are going to be trying to prove theorems in functions. We have to take note that the composition of functions is not commutative. Now, that is not to say that we do not have functions which, if you compose them one way and change the result around, and change the order of the functions, you will not get the same answer. In some cases, some very unpopular cases, very rare cases, or the most popular one might be when you're composing a function with its inverse, the order does not matter. You will get the same result. But that is not enough to say that the composition of functions is commutative. For the composition of functions to be commutative, it has to be true in every single case. So, the composition of functions is not commutative. That is, f of g is not equal to g of f for every of course we are familiar with this symbol, not equal to, but this one might be new. For every or for all. So the composition of functions is not commutative. That is, f of g is not equal to g of f for every fg functions. Right. So the composition of functions is not commutative. Now, I hope that this audiovisual will satisfy the needs of those students who requested. This audiovisual is going to be relevant for the work that my students will do in a short while. So it is going to be very good if my students will take a look at that. But the students who requested this are not my students. As a matter of fact, the students who request this, they are in the United States of America. I'm in Jamaica. Although the entire world is right at your fingertips these days with this online teaching and the rest of it. But my students did not request this. But of course, my students, you're going to find this to be very useful in a week and a half from now. So I think that you should take heed to this. And for especially the students in the United States of America, especially Mrs. Kayla Clark, not Mrs. Miss Kayla Clark, I hope that this presentation of the composition of functions, I hope that you find it to be very useful and that you will watch it as many times as is necessary for you to get the full internalization of it. Thank you for supporting my YouTube channel, both students who are not mine and my very own students, and see you next time in the classroom. Goodbye.